go over this like the homework and like go through?
So 8.1, these are exponent rules that we've already kind of talked about, but this is like what is expected to know. So this is just kind of a prereq to the chapter of exponentials and logs. So let's go through just some of the exponent rules, and then we'll do some practice on that. So when you have two exponents that are side by side, y'all remember like our little things we did? When they're side by side, you add those exponents together. So if I had x squared times x cubed, then the answer would be what? X to the fifth. Good. When you have a power to a power, you multiply. So if I had x squared to the third, that's when you would multiply, and you would have what? X to the sixth. Yes.
It's kind of not important, but I know. So, you know how like x squared, it's like x squared and x cubed?
Mm-hmm.
So like, do like the exponents like 4 and above not have like a name or anything? Like it's just a number?
Like x to the fourth or x
Like,
to the
there's
fifth.
like
No.
cubes or
No.
X
If I had a power on the outside of a parentheses, that power, that exponent would get distributed. So let's say that I had 2xy squared. What would my final answer be? Or let's make it cubed. Or not to the fourth, sorry, cubed. What would that be? 8x cubed y cubed. And you have to treat every single term as something separate. So it gets applied to the 2, the x, and the y. And a lot of times people forget to apply it to the 2. They just kind of bring it along with it. But it's 8x cubed y cubed. If you have a negative exponent, what does that do?
It goes to the bottom.
It brings it down to the bottom. So if I had 3 to the negative 1 power, what would that? 1 over 3. Anything to the 0 power is equal to 1. So 10 to the 0 power is just 1. And if you have a power, if you subtract, or like if you have a fraction, like power over a power, a fraction, then you subtract those exponents. So if I had x to the fifth, actually let's make it a little bit harder. If I had x squared over x to the fifth,
Yeah, how do you do?
It would be 1 over x to the third.
it would be 1 over x to the third.
That's what I was going to say.
So you're still subtracting 2 minus 5, but you have negative 3. So that's why it stays on the bottom.
Oh.
No.
So basically what I normally do is I look at my two exponents and I say which one's bigger, the 5 or the 2? 5. So my answer is going to stay on the bottom. So like 5 minus 2 is 3, but the 3 goes on the bottom because it's bigger on the bottom. The exponent is bigger on the bottom. And then if you have a power on the outside of a fraction, that also gets distributed to the numerator and the denominator. So if I had 4/5 squared, what would that be? 16 over 25. Good.
Just go back down.
You can't simplify that any further.
You can't simplify 16
Oh,
over
right.
25?
No.
There's no 2. There's no.
Oh.
Yeah, those are good questions.
Because the
So-
exponent isn't applied to
The negative exponent, like whatever the negative exponent is applied to is the only thing that goes down.
And that's only.
But it's not connected to the 3. So the 3 stays on top, and then the x to the negative 2 goes down.
See, I would have done that wrong. Okay, cool.
Okay, let's look at some examples now. That's what these examples are for. So I want you to try number 1,
That's funny.
and I'm going to give you like 20 seconds, and then we're going to check it. Okay, this one, you're just adding the exponent. So x to the 16th, y to the 21st.
Good.
I don't even remember my boyfriend.
Try number 2. Okay, what do I do with this one?
You do the exponent, like squared exponent to the 3, then the x, then the y to the 2.
So it gets applied to the 3, the x, the y, and the z, and then it gets multiplied. But the 3 is squared.
Yep.
So the exponents are multiplied, but the 3 is squared to become 9. Okay, what about number 3? What would I do here?
3r over s.
3r over s. So the s is the only one with a negative exponent, so it goes down. Good. Okay, what about number 4? What would I do here?
Is this all only 8.1?
Uh-huh.
Oh.
This whole thing?
It's a lot of the same stuff.
No.
Okay, what would I do on number 4?
Oh, there's homework.
Subtract.
You subtract them,
Subtract them.
but then you can, like, just random.
So it's
Wait,
gonna
yes,
be-
then you can
X to
negative.
the 5 is on the bottom.
It's y
Okay.
to the top and then x to the fifth.
Y to the 4th on the top and x to the 5th on the bottom. So if you just highlight what's bigger, the y is larger on the top, or the exponent's larger, and then the x has a larger exponent on the bottom. So the y stays on top, the x stays on the bottom. Okay, what about number 5?
X, y.
1.
It's just 1. How come?
1 to everything because of the exponent.
Because the exponent is 0. Okay, try number 6. I'm going to give you a little bit of time. So normally what I will do is I will try to simplify this stuff in parentheses first before I distribute the 5. If you wanted to distribute the 5 first, you could.
How easy is this compared to the rest of the lesson?
I would say this is one of the trickier parts just because
Bull.
these people often make like simple mistakes on this kind of stuff.
Oh, great.
Okay, number 7. Yeah, what do I do here?
Are we foiling
Are
it?
you
Do
adding?
we add?
They're all on the same, like, even plane, right? There's not a power to a power anywhere. They're all same level.
So you do that.
So then you're just adding all the the like terms, exponents.
So you add them?
So
Yes.
2 and 10, though, they get multiplied.
Yeah. See?
The exponents get added. Numbers get multiplied. So then it would be x to the what? Y to the 6th and z to the 13th.
Oh my gosh.
Okay, on something like number 8,
Oh dear.
I would rather, this is my personal preference, I would rather make every exponent positive first, then simplify.
Does that mean we just flip it?
Which means you just flip it. So if you see a negative exponent, flip it. On the other side, it becomes positive.
So would that be...
So if I were just making every exponent positive, this x to the first power needs to come up, and then these two terms need to go down. So it would look like, the top would look like what?
X, Y.
3xy, and then the bottom would look like what?
Wouldn't it be 3x, y?
X squared, y to the 5th,
Z to the 4.
and z to the 4th. Good. Why is it z to the 4th?
Because it already has one, but then it's gonna
Yes. See, y'all are remembering that.
You can't forget the little Z.
So you combine it with the z that's already there. Now I'm going to simplify.
Oh. I got you.
So simplify the x's and the y's.
So 3 over
X, Y, 4, Z, 4.
X, y to the 4th, z to the 4th. Y'all are amazing.
Tell me about
That was so good.
literally a genius. Ready to take
That's a hard one.
No, it's not.
Yeah, it is.
There's literally no way this is the hardest lesson and that's a hard one. No, there's something you're hiding from us. I can see it in
You're
your
being
eyes.
secretive.
Okay, what about number 9? What do I do here?
Okay, wait, whoa, Avery.
First
Avery,
you
calm
do the
down.
X. Can we tie?
It's gonna be 1 over.
Oh, I know.
I'm going to let y'all just try it.
Third.
No.
So when you apply the negative
Gotcha.
Why
3,
is there a Z?
oh, that should be an S, sorry.
Should be.
Wait, why are they? Why is it? Oh.
So
Yep, got
negative 2 times negative 3 becomes r to the 6th, and then s 3 times negative 3 becomes s to the negative 9.
It's a PIMDOS, guys.
But
I put it over 1.
when you bring this back up, or since it's a negative, it comes up. It's now r to the 6th, s to the 9th.
But before you take it down to the bottom, you have to multiply it first.
Yeah. So I did it like.
So you did like 1 over r squared
No.
s cubed, and then did that to the negative 3, because that would work as well.
No, my final answer was R6 S to the 9 over 1.
Oh, that's fine. Same thing. Yeah, same thing.
Same thing.
Let me write it.
All right, here are some things that are expected that we know without a calculator. So let's try going through it. Okay, figure it out by yourself. Okay, make sure that you know how to do these without a calculator. So you might want to circle that or highlight it or something like that. So we've seen integer exponents, but the next thing we'll talk about is fractional exponents or rational ones. So if I have something like, have you guys seen these before ever?
I remember this problem on the test that we all,
Well, 25
I got wrong and then it was all
Oh, I
fine.
figured
And then
it
you,
out.
I
I
think
figured
got
this.
it
We
right.
put this on our final.
Yeah,
This was on the final?
We learned this at like the beginning of last year.
yeah, we did.
That's probably why this is
Well,
so
by
bad.
the way, I gotta.
Okay, well, let's talk about it again. So if I say x to the 1 over n, it would be like saying the root of that. So if I had, for instance, like, so if I had like x to the 1/2, it would be like saying the square root of x. If I had x to the 1/3, it would be like saying the cube root of x. Or if I had x.
have the 2 written in a little.
Yeah, why is it in like a little like section? Like I don't. Like what? Why is it a little 2?
Why is it like
In
in
the
the little
dip.
place thing?
Because that means like the squared root, the cube root, the 4th root.
What is the
I don't
formula?
know. That's
It's just like the 4th root, the cube root.
I don't think we actually ever learned
No.
this.
I
No,
really
I
Okay.
don't know.
Okay, if you have x to the m over n, all that means is you are taking the root of x and raising it to the m power. And this doesn't make sense right now, but it will in a second when we do lots of examples. So if I had like x to the 2/3, it would be like taking the cube root of x and then squaring it, like the cube root of x squared. So the numerator is like what makes x bigger, and the denominator is what makes x smaller. So for instance, if I said 25 to the 1/2, then what would I be doing to 25?
You make it a square.
The square root of 25.
over, and then the outside is 2.
Well, you know, when you just put square root, it's implied that it's 2. The only time it's not implied is if you had 3 or 4 or 5, like the 3rd root or the 4th root or something.
Would you count off if we put 2?
Nope, I would not. You can put 2 if you want. And the square root of 25 is 5.
Oh, there's 2 bugs. Oh.
But
Oh, cause like instead of it being.
So whenever it's 2, we don't need to put it there.
No.
Cause it's like you're saying like.
So it's like making it smaller.
It's like taking like half
Oh,
of
it's like
25.
You're taking the square root of it. Yeah.
So like. It makes sense.
Okay, for number 2, it's 7 to the 1/3. So what would that look like?
3 root 7.
yeah.
The cube root of 7. Can I do anything to that? No, so I just leave it.
I like that.
I like when we-
So this one's gonna be.
Okay, number 3, it's to the 2/3. So the denominator is what makes, it goes on the outside, and it's what makes that 8 smaller. And then the 2 is what makes it bigger. So it's, I'm going to write it like the 3 is on the outside,
Doesn't it say?
and then squared is on the inside.
Oh.
I like it.
So what I would do is I'm always going to go from small to big, and I'm going to write that up here first. So small to big, which means I'm going to do the cube root of 8 first. And so what times itself 3 times gets me to 8? 2. So that's going to look like 2 and then squared. 2 squared is 4. So that's what I mean when I say small to big. So do the cube root first, then go squared.
So why is the cube smaller?
The cubed makes it smaller because you have to think what times itself 3 times. Because 2 cubed is 8,
Yes.
right? So the cube root of 8 is 2. So it's like doing the opposite of cubing something. It's cube rooting it. Okay, number 4.
Well, then why did you square it after you cube rooted it?
Do what?
What?
Because this 2 right here. So it wasn't 1 over 3, it's 2 over 3.
Because when you do the 3 and the 8, like the cube root of 8, how many times? Like, a
So if
number
I had
equals to
8 to the 1 over 3, that would just be the cube root of 8, which is 2. And I would leave my answer like that. But by putting this 2 over 3, it now makes me need to square it, which then becomes 4. Okay?
Yes.
All right, number 4, I've got 9 to the negative 1/2. So what do you think that would look like? 1 over the square root of 9. Perfect.
Honest.
So 9 to the 1/2 is like saying the square root of 9, but then it's negative, so it goes to the bottom. So my final answer would be what?
1 over 3.
Good. Okay, 64, or negative 64 to the 1/3.
Is that an imaginary number?
Well, it would be if it were like the 1/2, but the 1/3 would be okay because you could multiply, because it's negative times negative times negative is a negative number. 3 times. So the cube root of negative 64, what's the cube root of 64? No, cube root. What times itself 3 times? 4. So it's negative, the answer is negative 4. Because if you think about it, if I do negative 4 times itself, yeah, you'll end up getting a negative 64.
Because 4 times 4 is
Yes.
Will we be responsible for any sort of root that doesn't go out evenly?
Yeah.
Will we be- okay.
Well, you would just leave, like we did for number 2.
Okay.
It doesn't, so you would just leave it as is.
I see some line.
Okay, try number 6. So you're going to go small to big. Small to big.
Okay.
Oh, number 4. So the negative 1/2, like the one on the top, like represents that one.
Mm-hmm.
What is it with 9?
27. So what I did is I went small. So the square root of 9 is what? 3. And 3 to the 3rd power is 27. Okay, number 7, I don't have it. I'm not going to scroll down because I don't want to lose all this. But I've got 125 to the negative 2/3.
Okay, wait, I think I made
So try this one. So I usually prefer to do the negative at the end and just put it 1 over the number that I get. So if I think about 125 to the 2/3, I'm going to go small first. So what is the cube root, or what times itself 3 times gets me to 125? 5. So then I have 5 squared, which is 25. And we can't forget about that negative, so it's 1 over 25. Perfect. Okay, so here's 8 through 10. Any questions about those? Okay, just a second.